Hi everyone, here we are with chapter 9 and this is called Stoichiometry. So for chapter 9 we're going to split it into two different parts. So part 1, which we're going to do this week, we're just going to practice and learn how to do basic stoichiometry. And then next week we're going to do more advanced stoichiometry. All right, so stoichiometry is basically the process of how we calculate how much reactant we need in order to produce a certain amount of product. All right, and so here are the few things you need to know. You need to know mole ratios. So mole ratios we get from the balanced equation, and we get that by looking at the coefficients from the balanced equation. And so I'll show you through the process of where that will fall into place. But these are your basic steps when you're going to do a stoichiometric calculation. So step number 1, if it's not in moles already, you're going to convert it into moles. Okay, so it always has to be in moles first. Once it's in moles, then you're going to use the mole to mole ratio to get to your desired compound. Okay, and I'll show you how to use the mole to mole ratio. The last step is you're going to use your mole roadmap or just, your mole conversions that you might already have memorized, and you're going to convert it to the units that it's asking for. So remember, if it's asking for grams, we use the periodic table to find the molar mass. If it's asking for particles, we use Avogadro's number. If it's asking for liters, we use 22.4. Okay, so let's go ahead and start right here with this sample problem. Nitrogen plus hydrogen gives you NH3. So before we can even get to the 3 steps, you always need to make sure your equation is balanced. So let's go ahead and balance this out. So let's see. We see the H's. There's 2 on the left, and then there are 3 on the right. So 2 here, 3 there. So what's a common multiple between 2 and 3? 6, right? And don't forget, when you balance equations, you can only add coefficients in the front, okay? So to make this one 6, what do we have to put in the front? A 3. And then to make this one equal to 6, what do we need to put in the front there? A 2. Okay, so that will balance out the H's so that we have 6 on each side. But by putting a 2 here, it changes the nitrogens to 2, and then look, it fixes that right there. So we have 2 nitrogens on the left, 2 nitrogens on the right, 6 H's, 6 H's. So now the equation is balanced, all right? Okay, now that it's balanced, we can actually get to the question. So go ahead and read this question to yourself first. So how many moles of ammonia are produced when 0.60 moles of nitrogen reacts with hydrogen? Okay, once you read it all the way through, then I want you to underline the question. Oops, pen. Okay, underline the question, how many moles of ammonia? And then underline the number, 0.6 moles of nitrogen. Those are the only 2 pieces of information that we will need in order to solve this problem, okay? Now what I'm going to do is I'm going to place them in the equation, so it's just easier to see with like what we have and where we're going. So how many moles of ammonia? Ammonia is NH3, so this is ammonia here. And since that is our question, then I'm going to write moles underneath it, because we want to calculate how many moles we have of that, and I'm going to put a question mark. That is what we're trying to find. The next thing is we're going to write the number, 0.60 moles of nitrogen. So we write that into the equation. Just underneath nitrogen, we have 0.60 moles. Okay, now the next thing that we do is I'm going to draw an arrow. I'm going to draw an arrow from the number going towards the question mark. Okay, so I draw once again an arrow from the number going towards the question mark there. So the number is where we are starting, and the question mark is where we are ending. All right, so now that we have that written out, it's just easier for us to organize the information. Now we can actually set up our equation, our calculation here. All right, so we always start off with the number that's given in the problem first. So 0.60 moles of nitrogen. Draw the time sign and draw the line. So now what we're going to do is we're going to go through our 3 steps right here, our 3 steps. So the first step is, if it's not in moles already, convert it to moles. Okay, good thing for us, it's already in moles. Okay, now go to step 2. Use the mole ratios to get your desired compound. So this is where I'm going to show you how we use a mole ratio. A mole ratio is the bridge going from one side to the other. And once again, the mole ratio we get from the coefficients from the balanced equation. So the one that we're going to, see where the arrow's pointing towards? That one goes on top, okay? So wherever you're going to or going towards, that is the one that goes on top. So we're going to put a 2 on top. And these coefficients, or the mole-to-mole ratios, these are moles. So we call that 2 moles, okay? So the coefficients, so this is like 2 moles, this is 3 moles, and then this is only like 1 mole, right? So we call this 2 moles. We write that on top. So 2 moles of NH3 goes on top. Then the one that we were leaving from goes on the bottom. So what's the coefficient in front of nitrogen? It's a 1, so that goes on the bottom. 1 mole of N2. And then you can see here, that's what we wanted. This is in moles of nitrogen on the bottom, so that those can cross out. So we can cross out those units. Okay, then we go and we look at the third step. So we used the mole-to-mole ratio. So the mole-to-mole ratio is like a bridge. Okay, it's like a bridge connecting one side to the other. All right, now by using the mole-to-mole ratio, now we're over here on this side. We're now towards the ammonia side. Look at the last step. Use the mole-to-mole, or use the mole roadmap to get your desired units. So we go back, look at the question, and what it's asking for. It's asking for moles. Okay, it wants our answer in moles. So we look over here. By doing this and getting those to cross out right there, this will already give us our answer in moles. Okay, so then basically it's 0.60 times 2, and you can put that into your calculator. Don't forget to round to the proper number sig figs. Look at the number that you're starting out with to determine how many sig figs your answer should have. So basically 0.60 times 2, and round it to 2 sig figs, it'd be 1.2 moles of NH3. Okay, and so that is stoichiometry. Of course, we're going to do more examples. All right, so let's go ahead and look at the next example. Okay, so here we are at another example problem, and this one is going to use the same equation from the previous problem. So let's go ahead and rewrite that balanced equation so we have a fresh one to work with. So N2 plus 3H2 gives us 2NH3. All right, so calculate the number of grams. So we always underline what we're trying to find and underline the number. Those are the only 2 things that we will need in order to solve the problem. All right, so let's go ahead and write those underneath where they belong. So calculate the number of grams of NH3. So we're going to put grams, question mark there. And this time we're starting with 5.4 grams of hydrogen. Okay, then you're going to draw your arrow from the number going towards the question mark. Okay, so don't forget that we always start with the number and we're going to end with the question. Okay, all right, so let's go ahead and set the problem up. So start with the number 5.4 grams of hydrogen. So if you look at the steps for stoichiometry, first thing we need to do is convert it to moles. The reason why it always has to be in moles first is so that we can use the mole-to-mole ratio to make the bridge, okay? So if we have, don't forget, if we have grams here on the bottom, we want the grams on the bottom of the next step. All right, so we're going to have grams on the bottom, and then the mole on top. So anything with grams in it, we're going to use the periodic table. So you look on the periodic table, add up 2 H's. So you already know that is 2 grams per mole. Okay, then, so we convert it to moles. Now the next step is use the mole to mole ratio. So then we're going to use the bridge, and we're going to use the coefficients from the balanced equation. So the one that you're going towards goes on top, and we just use the number that's in the front. So 2 moles of NH3 go on top, and the one that you're leaving from goes on the bottom. So then the 3 moles of H2 on the bottom. And then the last step for stoichiometry is convert it to the units it's asking for. So let's see, it's asking for grams. So if it's asking for grams, then you know you want the grams on top and then the mole on the bottom. And so anything with grams in it, you're going to look on the periodic table. So that means you have to add up 1 nitrogen and 3 H's. Do not multiply that by 2, okay? Just find the molar mass of NH3. Don't multiply that by 2. The coefficient is already used in the mole to mole ratio part. All right, so you don't want to do that part twice. All right, so add up NH3, 1 nitrogen, and 3 H's, which should turn out to be 17 grams per mole. Okay, then always check your units to make sure that they cross out. Grams, okay, that's the grams of hydrogen cross out. Moles of hydrogen cross out. And these are moles of NH3, and those would cross out. Okay, because the 17 grams, that's all of the NH3 stuff. And that, you can see, will give us our answer in grams. So if the number is on bottom, it means to divide. If the number is on top, that means to multiply. So this is how I would put this into my calculator. I would type in 5.4, divide by 2, times 2, because that number's on top, hit divide by 3, because that's on the bottom, and then times 17. And then don't forget to round your answer to the proper number of sig figs. So if you do this correctly, and round to the proper number of sig figs, we only need 2 sig figs, so it should be 31 grams of NH3. Okay, and that is it. All right, so we have another sample problem. We're going to do 2 more sample problems, and so hopefully after we do these sample problems, it will get easier and easier for you. Okay, first thing you need to do is go ahead and balance the equation out. All right, so let's see, we have 2 H's there, 2 H's there, 1 O, but 2 O's on that side. So don't forget, we can only add numbers in the front. So in order to make this one equal to 2, what do we have to put in the front? A 2, okay? But then that changes the H's to 4, so then we make that one equal 4 by putting a 2 in the front. All right, so now the equation is balanced. All right, so underline the question and then also underline the number in the problem. Those are the only pieces of information that you need in order to solve the problem. How many molecules of oxygen? And then the number, 29.2 grams of water. So let's go ahead and write those in the problem. So let's see, 29.2 grams of water. So that's right here, 29.2 grams. Okay, 29.2 grams of water. Maybe let's just go over that in black. I can't really see it that well. 29.2 grams of water. And then how many molecules of oxygen? So oxygen's over here. Molecules. Question mark. Okay, then we're going to draw our arrow going from the number going towards the question mark. Okay, so let's always start off with the number. All right, so we're going to start off with the 29.2 grams of H2O. First step in stoichiometry, convert to moles. Always convert to moles first. So if we have grams here, we want the grams on the bottom of the next step. So grams go on the bottom, mole goes on top, and this is of H2O. So then you have to look on your periodic table, add up 2 H's, 10. And if you add that up correctly, it should be 18. Okay, 18 grams per mole. Now, second step is use the mole to mole ratio. So this is where we use the coefficients from the balanced equation. The one you're going to, where the arrow's pointing towards, goes on top. So the coefficient in front of that is a 1. 1 mole of oxygen on top for every 2 moles of water on the bottom. Okay, and then the last step is convert to the units it's asking for. This time it's asking for molecules. So molecules are particles, so we're going to use Avogadro's number. So that means Avogadro's number will go on top, 6.02 times 10 to the 23rd, and this will be molecules of oxygen. Okay, running out of room, and that's per mole. And then you can always just double check your units. Grams cancel, moles cancel there, and then moles cancel. All right, so you put this into your calculator. 29.2 divide by 18, divide by 2, because that number's on the bottom, and then multiply by Avogadro's number. Don't forget, when you see the times 10 part, to use your exponent key. All right, use your exponent key there. All right, if you did it right and round to the proper number sig figs, let's see, you should get, we need 3 sig figs, so you should get 4.88 times 10 to the 23rd molecules of oxygen. If you're having trouble getting that answer and your exponent is off a little, please make sure you ask me for help in class so that I can help you with your exponent key again. Okay? All right, one last sample problem. All right? Okay, this one here, I want you to try all by yourself. All right, all by yourself. So you should pause the video, do the problem, okay, as much as you can, all by yourself, and then press play and see if you got it right all by yourself. Don't forget to balance your equation, okay? All right, so I'm going to go ahead and go through that. Don't forget, you can only add numbers in the front. So let's see, 2 and 2, that's 4 O's, and that's only a 3 there. So if you balance this correctly, so let's try to make this an even number. So let's try putting a 2 in the front there. By putting a 2 in the front there makes the S's 2. So we had to put a 2 over there to make those S's equal to 2. Now add up the O's. 2 times 2 is 4, plus 2 is 6. Okay, and that's 6 O's there. Okay. Now underline the question and underline the number. How many liters of oxygen? And then we have 19.8 liters of SO3. So let's write those in the equation. How many liters, so liters of oxygen, that's a question mark, and then 19.8 liters of SO3, 19.8. All right, now we're going to draw our arrow. You can draw your arrow starting from the number going towards the question mark. Okay, so this time we are going from the right side to the left side. Okay, and that is okay. Yes, you can go from the product side to the left side. You can go to 2 things on the same side. All right, it doesn't really matter. So draw your arrow from the number going to the question mark. And that looks kind of messy, but hopefully you guys wrote it down nicer on your paper. Let me just fix that. It's bothering me. All right, so this is liters, question mark, going from here to there. Okay, so this time you should start off with 19.8 liters of SO3. Okay, first step in stoichiometry, convert to moles first. So this is liters here, so we want liters on the bottom. So our conversion for liters, 22.4 liters per mole. Next step, use the mole to mole ratio. So the one we're going to goes on top. So what's the coefficient in front of the oxygen? It's a 1. 1 mole of O2 on top. And then this goes on the bottom. 2 moles of SO3 on the bottom. Okay, last step is convert to the units it's asking for. It's asking for liters. So then we put it back into liters, and that goes on top. whatever you want your units in, that goes on top. And then the mole goes on the bottom. Double check, make sure all our units cross out, liters, liters, moles, moles, moles of oxygen, cross out. Okay, now you put this into your calculator. 19.8, divide by 22.4, divide by 2, and then times 22.4. And you should get, and you want your answer in 3 sig figs, so 9.90 liters of, and this is all of oxygen. All right, and that is it. So basically, that is what your test is going to be on. It's going to be approximately 5 stoichiometry problems, all free response. Problems very similar to this. Okay, so don't forget, always make sure your equations are balanced. Once the equations are balanced, you're going to convert to moles first. Always has to be in moles first. Once it's in moles, you're going to use the mole to mole ratio. And then the last step is convert it to the units it's asking for. All right, so just follow those 3 basic steps for all of your equations, and then hopefully you won't have any problems solving these problems. All right, okay, so that is everything for part 1. All right, see you guys later. Bye.